So what is important to us? Is the 8th term important? Sure it is, yeah, absolutely. The 8th term they told us was what? 75. And the 20th term, do we need to know that? Yes, absolutely. And they told us the 20th term is 39. Okay. So we're going to take these two pieces of information and we're going to put them into our explicit formula, not recursive, but explicit. Okay? So we're going to start with the 8th term. So that means we are going to start with our a sub 8. We don't know the a sub 1, right? That's what we're going after. So he's got to stay a sub 1. Plus, it is the 8th term, so my n minus 1 would be what? 7. Minus 7. Right? The n minus 1. If my n is 8, then this would be, no, 8 minus 1 would be, okay, so it would be 7, and we don't know difference. We don't know the difference. They did tell us what that equaled, though, which was what? 75. Okay, you have an equation with 2 variables, right? So if you have an equation with 2 variables, if you have 2 variables, you have to have 2 equations in order to be able to solve for the A and the D. Or when we did it in Algebra 2, we solved for the X and the Y. So we're setting up a system of equations here. So you need to think back to Algebra 2 when we did our systems of equations. Let's do the second one, our A sub 20. Okay, that is our A sub 1 plus, what are you going to multiply? What's your n minus 1? 19. And they told us the A sub 20 was 39. So here is your system of equations right here. 2 unknowns, you must have 2 equations. You learned in Algebra 2 how to solve these. We had 3 ways. We could graph them and find the intersection. We could do substitution. Or we could do elimination. Remember which was your multiplication. Okay? In this case, this one is set up already where your variables are on the same side of the equation. So this one is already set up for you to do your elimination process, right? So your elimination process is, remember, I'm looking at these. I need to get rid of either the A or I need to get rid of the D. Okay? What do we look for? We look for the variable that has the same coefficient. Which variable has the same coefficient? The A sub 1. It has a coefficient of 1. Now, if I'm going to add these two together, if I add this one to this one, I'm going to get 2. I don't want that. I want to get rid of it. So if I have a 1 here, what do I have to add to it for this to go away? Negative 1. So in order for this to become a negative 1, what am I going to do to this, what? Yes. So I'm going to go through and I'm going to multiply it by a negative 1. What I do to one side, remember, we do to the other. So we're going to go through, we're going to multiply negative 1 on both sides. Distribute that in. So that would make this a negative A, this would be a negative 19, and this would be a negative 39. Okay, now let's add them up. So now what happens, nice and neat, right? This positive 1 added to this negative 1, what happens to the A sub 1? They cancel out. Okay, now the 7D plus the negative 19D now. Negative 12D. And then the 75 plus the negative 39. I think it's 36. So we now have a difference. What's our difference? What's our difference? Negative 3. All right, so we found our difference. We're halfway there. Now we need to find our A sub 1. So now you're going to go back. You're going to choose one of those equations. I'm just going to choose the top one just because. And we're going to sub back in the D value to find our A sub 1. So that means I'm going to have a sub 1 plus the 7 times the difference that we just found. And we know that that equals 75. So if we solve that, so this would be a sub 1 minus 21 equals 75. Moving your 21 over, a sub 1 would equal what? 96. All right, so we have found A. We've got to know those to write recursively. Okay, so now we're going to write our formula. So now we're going to do B. Okay. To write recursive, what's the very first piece of information they always give you? A sub 1. We found that to be what? 96. So a sub 1 equals 96, comma. And then we're going to have the a sub n equals. So our term, a sub n minus 1, plus our difference was a what again? Plus the negative 3. So there's our recursive. So remember what's going to happen? Since this is recursive, this is going to change every single time, right? As you proceed to the next terms, just like we did on the warm-up. This a to the n minus 1, right? We'll start off with the 96, okay? And then 96 minus 3, we would start the next one with 96 minus 3, we would start, then the next one would be 93, right? And we would continue, recursive, okay? So then that just leaves us to write the nth term of the sequence. The nth term, what are they asking you for? They're asking you for the explicit. They just want the explicit. You've had plenty of practice on that one. So for our explicit formula, so come on. Our a sub n equals, what was our first term? A sub 1? 96 plus our n minus 1. Our difference was a negative 3. So let's simplify that down. So negative 3n plus 3. 96 plus 3, so 99 minus 3n. And there is your explicit. There you go. Your explicit and your recursive. Okay, so we've established that consecutive terms are terms that come one right after the other. So if we're talking about the arithmetic sequence, right? 1, 3, 5, those would be consecutive, one right after the other in an arithmetic sequence. And we know from arithmetic sequences that their differences are constant, or we would say they are the same, right? So what we're going to do is, knowing those two pieces of information, we're going to find the value of x. So in order to find that common difference, we subtract the two consecutive terms, right? So we're going to do that as well here. It's just that they're not numbers, they are algebraic expressions, but the process is still the same. So let's do it. So we're going to subtract our first two terms. So we're going to take that 3x plus 1, and we're going to subtract the x plus 2. That x plus 2 is an expression, right? So that expression must absolutely have the parenthesis. You don't put the parentheses around that, you are not going to distribute your negative sign, and you will get this wrong. So be very, very careful there. All right, so let's simplify this down. So that essentially is a 3x plus 1 minus x minus 2. And what would that simplify down to? Hold on. It's like, why did I put a 2? There we go. There we go. Okay. So that, what did you say, Matthew? 2x? 2x minus 1. Okay. We're going to do the same thing again for the next two consecutive expressions. So let's do those two. So that is the 3x plus 1 and the 6x plus 2. So we will repeat our process. So we're going to take that 6x plus 2 and subtract the previous term of 3x plus 1. Again, please make sure you're paying attention to those parentheses. So that would be negative 3x minus 1, and that would simplify down to 3x plus 1. So what did we just find? We found the what? We found that common difference, right? So now what do we know about these two expressions? So that means essentially what? Yes, well, we know it's an arithmetic series. What do we know about the differences of arithmetic series? They're the same. Okay? So what does that tell us about these two algebraic expressions? They equal each other. It's that common difference, right? The x plus 2 and the 3x plus 1 have the exact same difference as the 3x plus 1 and the 6x plus 2, right? Because it's arithmetic. So how would we set this up to solve for x? Yes, the 2x minus 1 equals the 3x plus 1. Exactly. All right, so solve that and find x for me. Okay, x equals negative 2. Is that what you got?
Yes.
Okay. So let's write down our summation. So we have to get all of our information to fill out or to replace into our formula. So let's start off with the ceramic tile floor is designed in the shape of a trapezoid, 20 feet wide at the base. What are they telling you right there? That's your what? A1. And 10 feet wide at the top. What are they telling you there? It's the 10 is your what? Your end. Yes. So, yes. So, I'll do M over here. Base of M is 10. Okay. What do we need to find? We need to find the n. The n in this case is our what? It's the rows. How many rows do we have? Can you see it? No, it's kind of hard. How many rows do you count? 11. Do you see 11? It's 11. It's 11 rows. Yeah, I know it's kind of hard to see. So actually there are 11 rows. So the rows that's how far we went, right? That's our nth term. Okay? So all we have to do is put all that in. So our 11 for our nth are 11 rows. Our starting number of 20 bricks plus the end of the bricks. We ended up with 10 in that top row, right? And it is less because we were decreasing by 1 each time. Okay. So how many bricks are we going to use? 165. The Drury Lane Theater has 25 seats in the first row. What is that information? Absolutely. That's your A1. And 30 rows in all. AN? It's the nth. It's the N. Yes. I'll do this. Good. We need to find the nth. The nth is what we don't have. The explicit formula. We don't know. We know we're going to go out to 30, but we don't know how many seats are in that row of 30, right? But we can find that. We can find that. Okay. Oh, one more thing before we do that, because we need to know this. What does each successive row contain one additional seat mean? Plus what? And that is your, all right, let's put it together. So we're going to find, so we need to know in order to do our formula, I'll write them down here, our summation. We have the n, we have the ace of 1, but this is what we don't have, the ace of n. We know we're at row 30, and we know we start with 25 seats. We can find this because we're going to sub it into our ace of n, so let's do that. All right, then your ace of n, you take the ace of 1 plus n minus 1 times that difference. Specifically, we're looking at ace of what? 30. We're on row 30. How many seats are on row 30? Okay. Ace of 1 is 25. N minus 1. 29. And what was our difference again? 1. So how many seats are in that 30th row? 50, 54. Okay. Now let's put it all together. So our S of n, what am I going to put again n for the n? 30. Maybe. It's not going. Ace of 1 plus how many seats? Yes, 1185. So 1,185 seats. Very good.